Hello, Assalamu alaikum. Can you hear me? Okay. I think we had started this topic or last time we were here on this topic and we discussed that the Fleming's right hand rule for magnetization of a coil. And this is our topic today, methods of demagnetization. So give this heading, methods of demagnetization. If you're not using the mic today, you can update me on the chat. So give a new heading. Give a new heading, methods of demagnetization. Now, this is a concept. We are starting with this concept today. Look, the concept says that whenever you have a magnet and you want to demagnetize it, it means that you want to get rid of magnetism. Suppose you have some data stored in something. Suppose you have some data stored in a memory card and you want to delete the data. In physics, you have to demagnetize it. This is where methods of demagnetization comes. There are 4 main methods: heating, hammering, using an alternating current. So these are the methods to demagnetize something. So you can make the first concept for today, that demagnetization means you want to remove the magnetism. This is, for example, you have connected 2 iron rods by magnetization, and now you want to deattach them. So you need to demagnetize. These are the methods to demagnetize a system. This is, you have to copy this screen. No, I don't think so. You have not done this part. In my record, we did methods of magnetization. We haven't done method of demagnetization. Do you mean to say that you have copied it, or you are saying that we have done it in our class before? Acha, you have written this method. Okay. So let's start with heating. Heating is a very common problem, and you must have heard that in mobile phones, you can't, the mobile phones or other media of data storage should not be subjected to high temperature, like computer hard drives, memory cards. They can lose the data if they are subjected to high temperature. So heating is something which is not good for magnetization, because by heating, the system can be demagnetized. For example, data loss occurs when data loss occurs at high temperature. Then hammering comes. What is hammering? You put a magnet and you hammer it gently. This is how hammering is involved. If you hammer a magnetized material, it will be demagnetized. For example, when you have a new, when you have an ammeter or voltmeter, you gently tap it like this. What the tapping will do, it will demagnetize the needle if it is magnetized. Okay, after copying, if this list is copied, write under it that heat is a form, number one, heat is a form of energy. Right, number one, heat is a form of energy. Heat is a form of energy. It can demagnetize. It can demagnetize a magnetized material. It can demagnetize. It can be demagnetized by heating. For example, that right in the next line, for example, data loss. So write this thing, for example, data loss. For example, data loss at high temperature. So for example, you have a computer or you have a memory card, you have a hard drive. So they should not be subjected to high temperature because they can lose the data. Okay, now number two, hammering. Give a side heading, hammering. So give a side heading, hammering, and write under it that place the magnetic material in reverse polarity of the earth. Place the magnetic material in the reverse polarity of the earth and gently hammer it Okay, now this is the method which is called hammering. Now take the example, for, right under it. For example, uh, place the magnet in the reverse polarity of the earth and gently hammer it. And gently hammer it. Okay, right under it. For example, copy this screen. For example, tapping. This is called tapping. So we gently tap these meters. This is called hammering. Actually, the word hammering does not mean the physical strong hammering. It actually refers to a method of gentle hammering. Okay, now number 3, using now number 3, using an alternating current. Using an alternating current. Number 3, using an alternating current. This is number 3. You have to give this heading, using an alternating current. Now, remember that in our last class, we have discussed that you can magnetize using direct current. But here we are now discussing using an alternating current. Now, alternating current can be used to magnetize. In our older class, we had discussed DC, direct current. DC was used to magnetize. DC was used to magnetize. DC was used to magnetize a material. Now look at this case. This is an electrical circuit, but now I'm using alternating current AC. I have a magnetized rod. I have a magnetized rod and I am connecting it with an alternating supply. When the switch is closed, electric current passes through the solenoid. Now, when electric current passes through the solenoid, after some time, you have to pull out the magnet. You have to pull out the magnet from the solenoid. Once you pull it out, it will be demagnetized. It will be demagnetized. And what happens inside the iron core? Look, the polarity due to alternating current switches its polarity like this. So alternatingly, the polarity of the magnet switches. Now, when you pull it out, it will be demagnetized. So now make the concept. If you use DC, the rod will be magnetized. If you use AC and you pull it out, it will be demagnetized. This is the concept of demagnetization. So now we make this concept, give the heading. Number three, using an alternating current. This is an AC supply, and we have placed the magnetized iron rod. You have to copy this diagram. Hmm. Now, let me know once you have copied this diagram. Hmm. Okay. Now, what is the concept? If you use DC, you will get it magnetized. If you use AC and you pull out the magnet, when you close the switch and allow the current passes through the solenoid, this is how you have to do it now. Now the magnet is gradually removed from the solenoid. You have to take it out and it will be demagnetized. Internally, this happens. Look, actually the polarity of the alternating circuit is continuously changing. This will shuffle the magnetism and the rod will be demagnetized. So now right under it, close the switch, close the switch, close the switch, and gently remove the magnetized iron rod, and gently remove the magnetized iron rod, gently remove the magnetized iron rod. It will be demagnetized. Now give a new heading, iron and steel. Give a new heading, iron and steel. This is our next title heading. Now we are making this concept. Now you have to make this concept that steel and iron are different in only in the title terms. Otherwise, actually, iron is an element and steel is an alloy. The main feature that both are iron. Now we first talk about iron. Now make the concept that iron is easy to write with me. Iron is easy to magnetize and easy to iron is easy to magnetize and easy to demagnetize. Remember, iron and steel are actually very close. Iron is the element and steel is the alloy. But when you try to magnetize iron, iron is ready to magnetize quickly. So iron is always easy to magnetize. Iron is suitable as a temporary magnet. Iron is suitable as a temporary magnet. For example, iron is used as a core in an electromagnet. Iron is used. So there are many electromagnets in our course. We will discuss them later. But iron is suitable where you need a temporary magnet. Where you need a temporary magnet. So you have to copy this screen. So when you compare iron and steel, you have to make a concept. If you want to make a temporary magnet, which remain magnet for a limited time, you have to use iron. And for example, electromagnets are there. Electromagnets are those which are current-based magnets and they remain magnet for a limited time. Now, let's talk about steel. First concept comes steel is an alloy of steel is an alloy of iron. Originally, it is iron, and we just modify it to become a magnet, become a magnetic material. Steel is much harder. Steel is much harder than iron. It is famous for its strength, stiffness. Now, make a concept that steel is hard. Steel is hard to magnetize. And hard to demagnetize. Steel is hard to magnetize and hard to demagnetize. You have to copy this screen also. So you can compare now that there are two types of materials, iron and steel. Now, iron is used when you need a temporary magnet, and steel is used as a permanent magnet. For example, core of a motor. The core of a motor is a permanent magnet. When you want to make a permanent magnet, you should select steel. So if you want to make a temporary magnet, you can use iron. And if you want to make a permanent magnet, you can use iron. So you have to copy now this. Let me know once you have copied this whole screen. Good. Now give a new heading, magnetic field. Give a new heading, magnetic field. This is our next title of the chapter. Heading is magnetic field. In the previous, in our chapter, electric field, we made a topic, electric field. In electrostatics, we did a topic, electric field. Now, we have to see the definition. A magnetic field is a region in which a magnetic pole experiences a force. Actually, it is a concept of range. So when you put a magnet, it can attract other magnet within a range. In this range is called magnetic field. So now copy the definition. This is the definition. Magnetic field is a force field. And I hope you remember this topic when we did our first chapter, electrostatics. So I did that concept that actually field is a region where you can experience a force. So like other force fields, magnetic field is also invisible. So it is represented by imaginary lines of forces called flux. So we draw these lines. These are called field lines. This is a common rule to remember, that in physics, all types of fields are represented by imaginary lines. These lines are called field lines. Look, this is a phenomena which is not visible to us. So we draw imaginary lines. This is called a horseshoe magnet, left one, and the right one is called a bar magnet. In paper, you can find many questions where you have to draw these lines. Now, you have to write under it that a magnetic field is represented by a magnetic, write under it, that a magnetic field is represented by field lines. A magnetic field is represented by field lines. So these are called field patterns. So now give us side heading, field patterns, and you have to copy this pattern. You have to copy it neatly. You have to copy it neatly.
Can you repeat the previous sentence?
Magnetic field is represented by field lines. Magnetic field is represented by field lines.
You said something after that. So these are called
Field lines or flux. These are called field lines or flux. These lines are directed from north to south. This is an assumption. This is an assumption only. So these are called field lines. The direction of the magnetic field at a point is the direction of the force on the north pole of a magnet at that point. You have to copy this concept now. Let me know once you have copied it.
done.
Okay. So we keep it up to here. I'm sorry, I have a back-to-back class, but I will compensate this time, inshallah, in any next class. Okay. Thank you. Bye.